In this part of the video, we are going to discuss how are you going to shift a function vertically and horizontally. A function that is given, say y equals to f, it would have a shape. Right? Usually the functions say this is a function of y equals to fx. You can shift the graph vertically up or vertically down, shift it to the left or shift it to the right. So say you have a function that is looking like y equals to x squared. So this is the original function of y equals to x squared. So you can shift it up by 1 unit, then you obtain this line. So this is a line of a function that is shifted from y equals to x squared, which is the blue color line, by 1 unit up, and shift it down by 2 units, then you obtain a new graph. So basically, if you are given a function, you can plot the graph, then you should be easily able to figure out the shape and size of a function that is shifted vertically by this much unit or that much of unit. Now, the other aspect of the shifting of the graph is that not only you would have to reproduce the shape of the function by shifting it upwards and downwards, you would also want to know what is the functions of the shifted graph. Now, for example, in this figure 1.54, the original function say is y equals to x squared. The graph is like this, right? So you can easily move the graph 2 units above. So you take, for example, this point, which is originally 0. You shift it to a point which is like 2 units above the x-axis. Then not only this point is shifted by 2 units, every single point is also to be shifted by 2 units. So if you have a point here on y equals x squared, then you shift it by 2 units. Then you join up all the points that has been shifted from the original graph y equals x squared into a new graph, where the new graph, let me call it y1, is a graph that is shifted from y equals x squared vertically by 2 units. Then what is the function of y1? So that is a very simple question to answer. The graph that is shifted plus or minus a constant of k is the new values or the new functions of a shifted graph. So we can demonstrate this very easily by using Mathematica. Say you have a graph, maybe I'll just do it like this. So I have a graph of yx. So let me plot the graph for x squared to be like this. So if I want to shift the graph by 2 units, the new graph that I'm going to get, let me call this new graph a function of y1. Now the formula for y1 is just an values of the function y1, so a function of y added with the amount of shift you want. Say for example, I want to shift it by 2 units. So that would mean that I'm constructing a new function based on the original function, where each values of the function at x is added with a values of 2. So this new function y1 would be a function which is shifted at 2 units above the x. So if I were to plot this function y1, then you can see very clearly that the y1 function, well, you can't really see very clearly. Yeah, I think so. So you can't see it very clearly because these two graphs seems to be merging very closely. Maybe I should just display the windows for the two function for y equals to from 2 to 2, right? So this is the function of x squared. So this is the original function. So every point here is shifted 2 units above. So here, if you have a function of y evaluated here is 1. So this point at y equals to 1 become y equals to 3, because every point on the function of y1 is translated into the function of y1, where the value of y1 is always 2 units above the function. So this y1 is then just equals to x squared plus 1. Okay, so it is actually quite straightforward to realize how you can shift a function vertically up or vertically down. So if you want to say shift the function by say 3 units down, then you just have to define the new function as the original function minus amount of unit you want to shift it downwards. So I plot this, then you can see that indeed the new function is shifted 3 units below. So every values of y has a corresponding values of y1, which is 3 units below. So if you look at this one, take the values of here and take the values of this endpoint, you will see that this gap is equals to 1. So all the gaps, vertical gap between the y function and the y1 function is indeed having a gap of 3 units. And this is the amount of shift you could easily change. Okay, so that is the definitions of shifting a graph vertically. How about shifting a graph horizontally? Right, so you can easily shift a graph horizontally like in this manner. Okay, so let me explain this a little bit more by writing on the whiteboard. So again, we are going to use the functions of y equals to x squared as our example. So the function of y equals x squared start with say from -1 to 1, and the function is say like this. So this is a parabola of y equals to x squared. You can perform the shift horizontal shift to the right, say by 1 unit. So it means that for every single values of x on the original function, you shift the x say to 1 unit to the right. Right, so say this is 1 unit. So this point is also to be shifted 1 unit to the right. So this point is going to be shifted 1 unit to the right. So if every single point on the original graph of y equals to x squared is shifted to the right by 1 unit, then what you get? So this point will be shifted here, this point will be shifted here. So then you get a new graph that would look like this. So maybe I should draw this with a different color so that you can see the shiftment more apparently. So this would be the new graph that will be obtained by shifting the original graph by 1 unit to the right. So this is a new graph that is obtained by shifting the original graph 1 unit to the right. And the new graph that is obtained here, I'll call it say y1. This y1 is a new function which could be constructed from the original function. So if you are shifting the graph to the right by say 1 unit, then the new function y1 is then just equals to the function of y, where you replace the expression of y, the expression of x in the function of y by x plus 1. Now let me explain what you mean. Plus 1 here means, sorry, not plus 1, it should be -1, not plus 1. So I'm sorry about that. So this should be x minus 1. So if you replace all the expression in the original functions, so if you replace all the expression of x in the original function by x minus 1, you would arrive at a new function y1, which is y, the argument of x replaced by x minus 1. So let's see what you can get from this. So the function of y is x squared, right? So if the x squared is to be replaced by x minus 1, what you actually do is that the x squared is replaced by x. X squared is to be replaced by x. Minus 1. So this is the expressions of x of y1, which is obtained from the original function y by replacing the argument of x by x minus 1. So x become x minus 1, then the function of original function of y is the square of x. So here, after replacing the x by x minus 1, then you square it. So that expression is a function that is similar to the original function but shifted 1 unit to the right. So let's see if this is true. So I'm going to have a function of x squared, and if I define function y1 by saying the values of x in the y is to be replaced by x minus 1, then the function of y raise the function of the argument x to the power of 2. So I'm going to raise the power of 2 as well. So y1 here is the expression obtained from y by replacing the x by x minus 1. Then after that, you have to raise it to the power of 2. Then I'm going to plot these two functions. I'm going to see that the function of y1 is similar to what I have drawn here on this screen. So you see the graph of y1. So this is a graph of y. This is a graph of y, and this is a graph of y1, which is shifted to the right by 1 unit. Okay, so let's see if this is true. Then I think this is true, but it's not as obvious because it's sort of like two graphs looks different, but actually it's not different. It's just the windows are not displaying the full picture. So if you look at this function, the original function is y1. Every single values of x in y is shifted right by 1 unit. Okay, so all the points here is shifted. So all the point here, say for example, you take a point here, you shift it by see here is 1 unit. Yeah, so if this point is shifted by 1 unit, this point will become here. Okay, so so you take the point here, you shift it by 1 unit, then this point will then become the values of here. Okay, so this point become here. So what I'm saying here, I can't draw it correctly, but if you can follow my my mouse, let's see if I can do that. Okay, so this point is shifted to here. Every single point on the blue line is shifted to the right here. If you have a point here, this point is shifted 1 unit to the right. Okay, so what I'm saying here, that this is a function of y1, the orange color y1 is just a shifted version of this original function of x squared to the right by 1 unit. In other words, if you were to shift it by say 2 units to the left, what you should do is just to replace the x by x plus 2. Okay, so y1 is a function that is obtained from y by replacing x by x minus 1. If you were to form a new function y2 from y by replacing x with x plus 2, here you add to the x with a constant 2 instead of subtracting it with a unit of 1. This effectively means you are shifting the graph of y to the left by 2 units. And the expression of y that you would obtain by shifting x with x plus 2 is just you have an x replaced by x plus 2 and you square it. So this is the expression of y2, and if you plot this graph out, you will see that it would represent a functions of y equals to x squared but shifted to the left by 2 units. So I think this is 2 unit in this case, 2 unit to the left. And let's see if this is true. So I'm going to have my function, I call it y2. y2 defined to be the function of y, where the expression of x is to be replaced by x plus 2. Okay, so this is obtained by replacing x in y by x plus 2. And the new function obtained after this operation of substituting x by x plus 2, I call it the function of y2. So I can then plot the function of y2. You can see it for yourself how y2 looks like. So y2 is this function, and indeed it's a function that is shifted to the left by 2 units. So this is original function. This is the point of 0, 0. So this point of on y equals x squared is shifted 2 units to the left. It becomes like this. Okay, so it's just that the left hand side of the function for this green color thing is not printed out. But if I were to print it, you see that it behaves like this. Okay, so here we have an original function of x squared. You can shift it to the right by certain unit. That could be done by replacing x with x minus 1. If you want to shift the graph to the left, then you just replace the x in the function y by x plus 2. Okay, so that will shift it by 2 units. So to conclude, let me draw it here. If you have a function y equals to some function fx, you can shift it to the right by say k unit. In order to shift it by k units, what you need to do is just have to replace x by x minus k. Right? So replacing x by x minus k means you shift the function, and the new function that you obtain will be then the expression of f of x minus k. So let us demonstrate this with the example we have just expressed. So initially you have f equals to fx equals to x squared. So you perform the operation of replacing x by x minus 1, for example. In this case, we set k equals to 1. Then you get the new function, which is to replace the x by x minus 1. So you get x minus 1 squared. So this is a function that represents a function that is shifted right by 1 unit. So if you represent this by a graph, this would be a function of y equals to fx. Then the shifted function to the right by k unit is a function of y1, which is equals to the function of f, where x is to be replaced by x minus k. Right? Minus k means you shift it to the right. And in the same spirit, you could obtain the function that is shifted to the left. Then this function, I call it y2, can be obtained from the original function f by replacing x with x minus plus k. So you add to the function of x by x plus k amounts to having a new function which is shifted to the left. So in the previous example, we have seen if fx is just x squared, then y2 is just equals to x plus 2 squared. Okay, so this is a function that represents a function that is shifted to the left by 2 units. So that's how you can obtain the function of an shifted function, right? So this is a function that shifted 2 units to the right This is a function that shifted 2 units to the left. Okay, so this is another example. So you are given this function, I think there is an error here, which I have to correct it. So this is square, so 2, then there is a square of the 2. Okay, so obviously this function is a function that is shifted to the right by 3 units. This is a function of x shifted to the left by 2 units, and this is the original function. So you can easily represent the 3 functions on the graph here. Y equals to x squared, and then this function y equals to x plus 3 is just a function with minus 3. Yeah, okay, so this is this function, and this function is a function that is shifted to the right by 3 units. So this function is represented by a function that looks like this, okay, where this is 3. Okay, so there's not very complicated thing that I can tell you for shifting the graph horizontally, left or right. Now this is another situation where you have the original function y equals to f squared. So this is y equals to fx, which is the absolute function of f. So here we are having 2 types of operation. The first operation is the operation where you replace x by x minus 2. Right? So when you carry out this operation once, then the function of absolute x become x minus 2. Right? So after this operation, you get a new function y1, which is this. Okay, now these functions of x minus 2 minus 1 is obtained by carrying out another operation, that is you add to y1 with n values of minus 1. As we mentioned earlier on, adding or subtracting a constant to a function amounts to shifting the function up or down. So if you subtract from the function with a unit of 1, you are actually saying the graph that you obtain is shifted downstairs by 1 unit. So after these operations of replacing the y1 by 1, then this expression will become x minus 2 minus 1. And I'll call this function y2. So you start off with y equals to absolute of x. Then you carry out this operation for the first time to arrive at y1. Then you carry out another operation of replacing y1 by minus 1. You arrive at this expression y2, which is this expression. So it's a 2-step procedure where you are actually carrying out 2 shifts. The first shiftment is a shiftment of shifting the absolute function 2 units to the right. After you have done that, then you shift the function obtained by 1 unit downwards. So this is a 2-step procedure. So the result of the shiftment in the 2-step procedure is like this. So this is the result. Maybe I should show you more in detail of the operations. So initially you have this function, right? So these functions, you replace it by the x is replaced by x minus 1. Okay, I think this is the original question. No, minus 2. It's not minus 1. So this is minus 2. So when you do that operation, y will become y1. Y1 is just the expression of x to be replaced by x minus 2. So this operation can be represented on a graph. So this is a graph of the absolute values of x, and I'll call this y. So after you perform the operations, you get a new function of y1, which is a function which is shifted to the right by 2 units. So y1 is just a function which is 2 units to the right, and every single values of y is the same, except that the x value are shifted point by point to the right by 2 units. So the resultant values or the resultant graph y1 that is obtained by replacing x by x minus 2 in this operation is just, maybe I draw it with a different color. It's just this. Okay, so that is the function of y1, which is x minus 2. So now we have y1. Then according to these questions, we have to perform one more procedure of replacing the values of y1 by subtracting it with 1. Okay, so here we are going to carry out another operations. So this is way how I express my operation. My operation is that y1, that is all the values of y in the function, is to be replaced by y1 minus 1. Now in this situation, what do you get? In this case, all the values of y1 will be replaced by 1. So here you would get y2, which is obtained from y1, which is equals to y1 minus 1. I think that is the correct statements, where all the values of y1 is to be replaced by y1 minus 1. And then y1 is just expression of x minus 2 minus 1. So this is the results of displacing the function y1 by 1 unit below. Okay, so here you have y1, which is this function. Then y2 is a function that is obtained from y1 by plotting or displacing all the values of y by 1 unit below. So this point will be shifted down by 1 unit. So every single point here will also be shifted down by 1 unit. So this is the original function y1. You shift it down by 1 unit, then this is what you get. Okay, so this is a function of y2. So you compare it with the original function, which is this one. You shift it 2 unit to the left, then you arrive at this function. This is minus 2. And then this functions y1 is then shifted to y2, where this point is going to be shifted by 1 unit downstairs, and then you have this. So this is y2, where here every single point on the y1 and y2 are different by 1 unit. Okay, so that gives you this function. Okay, so that is an example of performing two consecutive operations onto an original function of an square of an absolute function. So the conclusion is that you can perform a shiftment of the graph either up or down, shift it to the left or to the right by using this idea of replacing y by y plus minus k, that is amount to shifting the graph vertically. Or if you want to shift it left or right, then you just replace the expression of x by x plus k or x minus k. When you replace the expression of x by x plus k, it means you shift the graph to the left. If you replace x by x minus, then you are amounting to shifting the graph to the right. Okay, so that is the idea of shifting the graph.